Hi out there, Mr. Grable. I want to talk to you a little bit about science today. What I want to talk to you about first is something called chemical reactions, and I'm not going to go into a great deal of detail about mapping out the chemical reactions. What I am going to ask you to look at today is two evidences of chemical reaction. And these two chemical reactions are called exothermic and endothermic. Exit means a door out of someplace. Exothermic means energy is going to be released into the environment during the chemical reaction. Endothermic, an entrance, is how you get into something. Endothermic means that energy is taken from the environment. Now, both of these things happen in chemical reactions all the time. What we end up measuring is what's called the net energy. All right? So I'm going to mix some things here, and you're going to see that some of them release energy. Well, they actually use energy too, but the net sum of the release and the absorption of energy will be different. So, how are we going to measure this? Well, we're going to use these handy-dandy thermal energy measuring devices, which are called thermometers. And let's not use a thermometer on this one. This is one of the most easy, I think, and in some cases maybe the most obvious, is this is a match. And it's a piece of wood with some chemicals on the tip of it. Now these chemicals, when they have been given enough starting energy, will start to react on their own, and they're going to release energy. We've all seen this happen before. Well, what happened here? We gave this match what's called activation energy, and then the chemicals on the tip of the match reacted because of the heat and the oxygen, and they released heat energy, a tremendous amount of heat energy compared to how much you put in. But not only heat energy, there's also light energy, and there's sound. Sound waves are being released. So that's one of our most obvious and easy examples of an exothermic reaction. How about an endothermic? I've got a beaker here, and in this beaker I'm going to put some apple cider vinegar. You can use any kind of vinegar. You could use hydrochloric acid, but most of us don't have that handy. I do. We're not going to use it today, though. We'll use it in a later demonstration. So I'm going to put the thermometer in there, and this vinegar has been sitting on my desk for a few days. So it's room temperature, which should be about 70 degrees Fahrenheit, or about 21 degrees Celsius. All right? These are kind of hard to read from a distance. You're going to have to trust me. Well, how about if I do this? There we go. All right. Now, I'm going to put in there some baking soda. The vinegar is an acidic solution, and the baking soda is a base. And when I put these together, there's going to be breaking of bonds and building of new bonds, but what we'll measure here is going to be the net loss or gain of energy. So put this in here. Oh boy, we've got a mess. I love science stuff. Here's a towel. this a minute to stop fizzing. There, like it never even happened. And now when I read my thermometer, we started at 21 degrees Celsius. It is 15 degrees Celsius now. So in the course of this reaction, instead of releasing a sum of energy to the environment, this reaction absorbed energy from the environment. And the temperature went down. That's our evidence. Evidence is that the temperature went down. We also have other forms of evidence in here. Evidence of the chemical reaction taking place could be that fizzing and the bubbling as well. Alright, let's rinse this guy off. And let's try a different one. I was brave and I went to the store the other day and I found some of these. Those of you who are hunters or maybe ice fishermen have used these before. Glove warmers or boot warmers. You just open them up and they magically produce heat. Well, not quite magically. Looking inside here, looking at the ingredients, ready for this? Contains iron, water, charcoal, vermiculite, polymer, and salt. What we're actually seeing when I do this is we're gonna see how iron interacts with the air. So how are we gonna get air? Well, we're just gonna open the bag. Right now, this bag's at room temperature, which is just like the baking soda or the vinegar is at 21 degrees Celsius. Now I'm going to open this up, and those of you who are hunters or fishermen, you know what's happening next. All right, and cut this open. I'm going to take out this pad. This sticks to your. This is made for toes. This sticks to the toe. Let's see what this does to our thermometer. I hope by the title of this thing you have a pretty good idea. So right now my thermometer reads 20 degrees C. When I was a kid, my dad had one that fit in our pockets, and they were filled with lighter fluid from like a cigar lighter, and it was horrible. Those things leaked all over the place. I got burns on my legs. I wouldn't advise that. I don't think they make those anymore. Right now we're at 72 degrees Fahrenheit or 25 degrees Celsius. So just in the few minutes that I told you the silly story about deer hunting when I was a kid, it's risen 6 degrees Celsius, and it feels warm to my touch. We're going to let that one go. I also have this. I found this at Walmart. Oh. And it says store at room temperature, so this is 21 degrees Celsius as well. And this is made for an instant cold compress, and maybe some of you have seen these before. This instant cold compress is used a lot of times by athletic trainers. Rather than having ice pack, they use these. And it says to activate, fold the product in half. Well, something has to happen in there. And some of you have probably used these before. You have to fold it, and what happens is the inner bag of water breaks and mixes with the contents, the dry contents of this. Well, what in the world is in this thing? Are you ready for this? Contains calcium ammonium nitrate. That's what this powder is. calcium ammonium nitrate, and we're going to mix it with water. Now we're not going to pour water in there. What did I tell you? The water's in there in a small bag, a bladder inside there. If we break that, then it exposes the rest of it. Let's take a look at our toe warmers. Right now it's at 30 degrees, 32 degrees C, which is about 90 degrees Fahrenheit. So our toes are getting nice and toasty. See what I did there? Okay, let's try this. So this is going to start at 21 degrees C, and we're going to put a cold compress on this. Alright? Notice how I'm not putting the thermometer over the edge of the desk so it breaks. I'm laying it on the desk. I have the triangular rings to keep them from rolling. We're starting at 21 degrees C. We're going to fold this. How do we know if this bag pops? Oh, did you hear that? Alright, mix, 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 mix. Remember, we're starting at 21 degrees C here. And hopefully by the title of this product, you know what's going to happen to this. Alright? Remember, an exothermic is energy is released, endothermic energy is absorbed into it. And these things happen simultaneously in the reaction. What we're measuring is the net release of heat or the net absorption of heat. Right now our toe warmers are at 100 degrees Fahrenheit, which is about 38 degrees Celsius. Our ice pack, we started at 21 degrees Celsius, it is already at 17 Celsius. So that the temperature is going down on this, the temperature is going up on this one. One of these is an endothermic and the other is an exothermic reaction. Alright, tune in next time. Maybe we'll do some things with colors. Maybe we'll do some things with density. I've got a lot of things planned, but keep tuning in.